So let's talk about limiting reactants. This is where you don't just have one bit of information, but you have two bits of information. You're given the amounts in some way or other, can be grams, can be pressure, volume, temperature, can be liters of solution, however it might be, that enables you to work out the moles of each reactant. From the moles of each reactant, you can determine the moles of product that each of those would have given you, and then you use the smaller number. So first question, aluminium oxide forms when aluminium reacts with oxygen, giving us Al2O3. A mixture of aluminium and oxygen allowed to react. What mass of aluminium oxide can be formed? So it's a grams to grams type of situation. Always the grams were made as Al2O3, so we can put that in there. However, we could think about starting with the aluminium, or we could think about starting with the oxygen. Which do we pick? Well, the answer is we have to do it twice. Let's start off with the A side being aluminium. Okay, so step 1, grams to moles. I'm just going to whiz through this relatively quickly. Step 2, moles to moles. We've got the equation. The Al2O3 coefficient is 2. The aluminium coefficient is 4. And so pop all that in, so we get 0.763 moles of Al2O3. And then step 3, which we might as well do now, tells us 77.9 grams. So in other words, by just using our standard old process, we have enough aluminium, 41.25 grams, to make 77.9 grams of Al2O3. But of course, that's not necessarily the answer, because now we've got to go back and we've got to say, well, we also know how much oxygen we had. So let's keep exactly the same thing now, except now oxygen is our compound A. Step 1, same idea, except now it's oxygen instead of aluminium, so the molar mass is 32, 1.84 grams of oxygen. Step 2, converted over. Well, now the coefficient Al2O3 is still 2, but the coefficient of O2 is 3. So that means we get 1.23 moles of Al2O3. Step 3 there, we have 125 grams. So previous slide, we got 77.9 grams of Al2O3 from the aluminum we had. We've now found out we could get 125 grams of Al2O3 from the oxygen, but we can only make the smaller amount. So therefore the oxygen, which makes the greater amount, is in excess, and the aluminium was the limiting reactant. Thus this is the actual answer. We have enough aluminium and oxygen to make 77.9 grams of Al2O3. We had oxygen enough to make more, but we only had enough aluminium to make this much. The aluminium limits the reaction. So phosphorus and chlorine react as follows. You're told here to balance it. I hope you wouldn't need that. Assume we have this much phosphorus and this much Cl2. What's the limiting reactant and how much of this final product would we make? So again, we have to consider this to be a two-part question. We have to figure out how much PCl3 we get from the phosphorus, how much PCl3 we get from the chlorine, and then compare them. So here's the step we're going to be taking. Again, grams to moles, moles to moles, moles to grams. Always PCl3 will be the B side because that's the product. And we'll start off maybe with P4 as our A side. So taking all the way through, step 1, molar mass is 4 times 31 because it's P4, and we get 1.008 moles of P4. Step 2, got to set up the coefficients in the balanced equation. Let's do it, shall we? 4 phosphoruses, so we'd need 4 PCl3s. 4 of those would be 12 chlorines, so we need 6 Cl2s. So there's the balanced equation. Coefficients of the PCl3 is 4. Coefficient of the P4, which is what we're interested in, is 1. Let's pop all that in. And we have enough P4 to make 4.032 moles of PCl3. Knock off the step 3 just because we can. And that's enough to give us 554 grams of PCl3. So the first part got enough P4 for 554 grams of PCl3. Now let's flip and make Cl2 the A side. All the way through, everything the same except first of all different molar mass because now it's Cl2. Different coefficients because the coefficient of Cl2 was 6. And so that gives us 3.03 moles PCl3, and that gives us a total of 417 grams of PCl3. So we had enough P4 to get 554 grams. We have enough Cl2 to give us 417 grams. Thus the Cl2 is the limiting reactant, and we can make 417 grams of PCl3. Just like I said. So 48.8 grams calcium hydride, 39.2 grams of water. So we've got grams and grams to start with for our two possible starting points. How many litres of H2 at STP? STP, you might remember from the gases, standard temperature and pressure. Volume of 1 mole at STP, 22.4 litres. Temperature, 273 Kelvin. Pressure, 1 atmosphere. So, pulling up the roadmap, regardless of which A side we start with, B is H2. Okay, but for each of the A's, calcium hydride or water, we start with grams, and for the H2 we want the litres at STP, so that's the pressure, volume and temperature down there. So step 1, grams to moles, step 2, moles to moles, and step 3, moles to pressure, volume and temperature. So we'll start off with calcium hydride as our part A. So step 1, very familiar, grams to moles. Step 2, very familiar, moles to moles, appropriate coefficients. The H2 has a coefficient of 2, the calcium hydride has a coefficient of 1, so that gives us 2.32 moles of H2. And then for step 3, we can use PV equals nRT. Pressure is 1 atmosphere, 2.32 moles, 0.0821 litre atmospheres per moles per Kelvin, and the temperature 273 Kelvin. That gives us 52.1 litres of the H2. So we have enough CH2 for 52.1 litres of H2. Now doing water as our starting point, remembering how much of the H2 we got from the CaH2. So grams to moles, again, very standard. Moles to moles, now the coefficients are both 2 because here H2 still for the B side, but H2O for the A side. So 2.18 moles of H2. Pop that into PV equals nRT in the same way, and we get 48.8 litres. So we have enough calcium hydride for 52.1 litres of hydrogen. We have enough water for only 48.8 litres of hydrogen. Thus, that is the limiting reactant. That is the amount formed. Finally, back to a grams and a grams and a grams. So there is our standard grams to moles, moles to moles, moles to grams. Always interested in SO2 on the B side. Two possible A sides. We'll start off with CS2. Again, I'm just going to click through it, make sure everything looks good. Always check these things if you need to. And so we end up that we have enough CS2 to give us 16.8 grams of SO2. So now O2 as our substance A, remembering that we had enough CS2 to make 16.8 grams of our SO2. So this is the number to beat or not to beat, depending upon your perspective. So standard again, grams to moles, moles to moles, using the right coefficients. SO2 is 2, O2 is 3, and then convert that to grams, and we end up with 20 grams of SO2. So we got enough CS2 for 16.8 grams. We have enough O2 for 20 grams. Unfortunately, 20 grams is too much. Thus, this is from the excess. So O2 is in excess, and CS2 is the limiting reactant.